And I'm going to share my screen. All right, so it's really important that we know how to reduce radicals in geometry, like throughout this whole course. We're going to have to know how to do that. Oh, Matthew. Maybe he left and came back. All right. All right, so in order to do that, it's good that we, oh. Hi, Rachel and Matt. I'm recording this lesson, so sorry. Make sure you have a pencil and paper because we're getting ready to take notes. All right, so it's important we know what the perfect squares are. A perfect square are two of the same numbers multiplied together. Like 1 is actually the smallest perfect square, and I do love that number because it's so easy to work with. 4 is a perfect square, right? And then we go up from there, 9, 16, 25, 36, 49. Sorry about my pen. It's really hard to write on the screen. 64. 81. 100. I'm just going to go to like 13, I think. 121. 144. And I believe it's 169. I am now having a brain fart. 13 squared. I'm pretty sure that's right. All right, does everyone understand what it means to be a perfect square? Right, because then we all know the root is the two of the same numbers that multiply together to make that perfect square. So when we're reducing radicals, an easy way to do it is if you look at number 1 here, I have the square root of 75. Are there any of these perfect squares that would be easy to go into the square root of 75? I always try to think about money because I love money. I don't have any, but I would love to have some of it. And if I had more of it, it would make my life easy. But I know that there are 3 25s in 75. So I can break this down into the square root of 3 times the square root of 25. We can do that. We can break it apart. Okay. The square root of 3 is not a perfect square, but the square root of 25 is. That breaks down to 5. So this becomes, oops, oh my goodness, 5 root 3. That is the square root of 75 reduced. Okay, I don't want you to put it in your calculator and give me a decimal because that's just craziness. Okay, we'll get there when we talk about trig, but that's in a long, long ways from now. All right, so number 2, the square root of 8. I want to break that down. Which one of these perfect squares up here fits into 8? Well, 4 does, right? So 8 is the square root of 4 times the square root of 2, right? Because 4 times 2 is 8. The square root of 4, well, you should all know this, that's an easy one, is 2. And root 2 does not break down, so that is just this expression right here, 2 root 2. I find it really easy to pull out the perfect squares and break it down like that. If you are struggling with that and you're like, oh, I don't know, there is another way to do it. I'll show you in this example for number 3. You can use what's called prime factorization. So then you also need to know what your prime numbers are. So prime numbers are numbers that are divisible by 1 and itself. So 1 is not prime. 3 is prime. 5 is prime. 7 is prime. 11 is prime, and 13. I'm not going to go anything beyond that. Those are all numbers that are only broken down by 1 and themselves. So for 27, I would start with the smallest prime number and say, oops, and say that's 3 and 9. And 9 can be broken down to 3 and 3. So when you do prime factorization, it's really important that the numbers at the very end are all prime. So I have a pair of 3s, and I have a spare 3, right? For every pair of numbers, 1 comes out front. And for every thing that's stuck in the square, it's going to stay underneath that radical. It's going to look like this. So the square root of 27 breaks down to 3 root 3. Oh my goodness gracious, someone just joined. Sedona, are you okay? All right, is everyone okay with what I've said so far?
My Zoom, like my whole Schoology was like down for like I was trying to get into it.
Okay.
And then I do have to leave like shortly. I'm gonna do an excuse note on Skyward. I have a driver's exam.
No, that's cool. So I'm actually recording this, and there's going to be, it's going to be posted. It takes like, I don't know, 5 minutes for it to upload into whatever file it is. And then I'll put it in the folder in September. It'll say notes, and then it'll have the date. So today will be 9/9/2020, okay?
Okay, thank you so much.
And if I make a pause, it's not the video's done. It's just me waiting for everyone to finish copying it down, okay?
Okay.
Because I listened to one this morning, and I was like, oh my God, it's awful, but sorry. And good luck with your appointment. Okay, everyone else that's here, is everyone cool for me to go forward? All right, silence is golden. Here we go. All right, so go ahead and try to do, actually, you know what? I'll do 48 and then I'll let you guys do 50. How about that? So 48, if I were to use perfect squares, I'd have to like get my calculator and run through and see like, all right, what are the perfect squares that go into 48? You can do that, but for this, I'm just going to go ahead and do prime factorization. So I am going to use 3. 3 goes into 48 16 times, right? And then 16. If you know, once you get to that point and you're like, oh my God, 16 is a perfect square, you can go ahead and do this and have your pair of numbers. And then this would break down to 4 root 3. If you wanted to keep going, and this is really tough because I want to make sure that like everyone learns differently, that I'm showing different ways, but I'm trying my best here. So let's say I started with 2. I wanted to break it down into 2 and 24. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So now I'm going to circle all my pairs. I have a pair of 2s here, a pair of 2s here, and I have this spare 3 goes in the square, spare square. All right, for every pair of numbers I have, 1 comes out front. So I have 1, 2 here, and I have another 2 here. If you have more than one number come out front, you multiply them together. And then this spare 3 stays in the hole, okay? I used to use an analogy like, it's a prison break, and you can only bust out of prison if you have somebody who looks just like you, but if you don't, you're stuck inside. Oh, maybe not a good analogy. Sorry. And 2 times 2 is 4 root 3. All right, we got the same answer here. So, you know, there's more than one way to go about this. Hopefully I'm not making this more confusing. So go ahead and take a minute and try to break down the square root of 80. And if someone has it, you can go ahead and hit me with it. Any volunteers to share your answer? Okay. Don't know. I said silence was golden, but maybe not. When I look at 80, I know it's going to be a multiple of 5. So 80 divided by 5 is So I could break this down to the square root of 5 times the square root of 16. And we know that the square root of 16 is a perfect square, so that this would simplify to 4 root 5. Done. If you want to do your factor tree like I kind of did in number 4, oh my goodness, I am so sorry about this. 240. This one could get a little long. 2 and 20. 2 and 10. 2 and 5. That's a 2. All right, and I circle my pairs. I have 1 pair. I have 2 pairs, and a spare 5. So remember, every number that comes out front gets multiplied together, and that 5 stays inside. 2 times 2 is 4 root 5. I still get the same answer. It really didn't take me that long, but that's we need to be able to break those down. So if you need more practice with that, you got to let me know. Is it okay for me to change the page? Okay. All right, the Pythagorean theorem, also something we are going to use all the time, okay? It only works for right triangles. That means that it has this 90-degree angle right here. It's the sum of the squares of the lengths of the legs, A and B, equal to the square of the length of the hypotenuse. This sounds craziness, but remember, this is the formula. A squared plus B squared equals C squared. So the 2 legs squared together equals the hypotenuse squared. Please make sure you're writing this down. You don't have to write this top part, but it's really important that you have this as a reference. Oh, I don't know if you guys can see that or not. Okay. Is everyone ready for me to move forward? Okay, so make sure that you're paying attention. Like, we're not always going to be looking for the hypotenuse, which is the longest side of the triangle. That's right here, side C. But in these 2 examples, we are. So just make sure we're setting it up right. So I always say, like, let's write the formula first. A squared plus B squared equals C squared. I do apologize for my handwriting. I'm using a spongy pen stylus. It's the best I can find. All right, and it really doesn't matter which side is A or B. It's like whatever number I look at first. The legs are, it doesn't really matter. So I'm going to say A is 3. So 3 squared plus 4 squared is equal to C squared. 3 squared is 9. 4 squared is 16 equals C squared. 9 plus 16 is 25 equals C squared. Sometimes people think they're done, but I'm not looking for C squared. I'm looking for C. So now I need to take the square root because that's how you unsquare something, right? It's all about the game of the opposite. So I'm going to take the square root here. The square root of 25 is 5. So 5 equals C. If you wanted to label your triangle, you could do like that. Normally I give guided notes and you guys would be filling this in, and I apologize, but the printers were like bananas trying to get ready for this whole thing. All right, that's all there is to it. So number 2, we're going to do the same thing, right? A squared plus B squared equals C squared. And like I said, it doesn't really matter which one's A or B. We know that the legs are 8 and 6. Doesn't matter. I see 8 first. I'm just going to go ahead and write that down. So 8 squared plus 6 squared equals C squared. 8 squared, 64, plus 36 equals C squared. All right, these are working out to be a little special here, right? Because we know 64 plus 36 is the honcho equals C squared. And don't forget, there is still one more step after you get C squared. You want to take the square root of both sides. And it's really nice when your number is a perfect square and you don't have to figure it out, but I can guarantee you that's not going to happen all the time. All right, so in this case, C, or the hypotenuse, equals 10. Okay. Is it okay if I go to the next page? You guys are amazing. I feel like I'm in a class all by myself. All right, remember what I said about right triangles? Like sometimes we're not always looking for the hypotenuse. In this case, the unknown side is a leg. So if we fill out that formula, right? Oh my gosh, that's an A. A squared plus B squared equals C squared. And let's fill in what we have. Well, we know we don't know what A is. A is our unknown. A squared. The other leg of the triangle is 16. If you're not sure which one's the leg and which one's the hypotenuse, you can always draw a ray from your 90-degree angle. This will point to the hypotenuse. So this is always going to be C. All right, so now we have B squared is going to be 16 squared equals 20 squared. Oh, these are big ones. I'm going to have to get out my calculator to figure this out. All right, A squared plus 16 squared. 16 squared is 256. And 20 squared is 400. Now it's like a two-step equation, right? I need to subtract 256 from both sides. And I get A squared equals 144. And now you know you must take the square root of both sides. And A equals 12. Yay. All right, awesome. Number 4, all right, we're looking for C, pretty straightforward. So I'm just going to start right ahead with the numbers. I don't want to waste your time. So 4 squared plus 8 squared equals C squared. Because A squared plus B squared equals C squared, right? Pythagorean theorem. So 4 squared is 16. 8 squared is 64 equals C squared. 16 plus 64 is 80 equals C squared. Now, here's the problem. 80 is not a perfect square. But I'm pretty sure we just found out what the square root of 80 was in example number 5. If you don't have that as a reference from the first slide, we can go ahead and do prime factorization, or we can like go ahead and try to divide by perfect squares. I know that 80 equals the square root of 16 times the square root of 5. Like, because 80 divided by 5 is 16. The square root of 16 is a perfect square. So now I have 4 root 5. That is the hypotenuse. It's not the nicest number. I'm not going to lie. It's pretty ugly, but it's reduced in radical form. So that's what you want to be able to do. I know it definitely trips up a lot of people. All right, number 5. Again, we're looking for the hypotenuse. So you can go ahead and set up your equation. 3 squared plus 5 squared equals c squared. 9, oh my goodness gracious, plus 25 equals c squared. 9 plus 25 is 34 equals c squared. 34 is definitely not a perfect square. If you're tempted to try to divide by perfect squares, you might get a little frustrated. Maybe you want to go ahead and try prime factorization and break it down, right? 34 is 2 and 17, neither of which, they're actually both prime numbers. So I'm not going to have any pairs. It doesn't break down. So in this case, your answer would be the square root of 34. I cannot reduce that anymore. That's it. That's its most reduced form. So maybe it's a gift or maybe it's a curse. I don't know. Depending on how much time you try to break it down and then end up back where you started, can be a little frustrating, but be aware. Is everyone okay if I go to the next page? All right. Then next thing I want to talk about, because this is basically a review, right? So now I want to talk about solving equations, okay? For number 1, this is a basic 2-step equation. You always want to isolate the variable, right? Get the variable on one side, get all the numbers on the other side, and then you're good to go, right? So in this case, I would subtract 7 from both sides and get 4x equals 20. To isolate the variable, I have to do the opposite. So I'm going to divide by 4 to both sides, and I get x equals 5. Some people out there really want you to go back and plug it in. I'm not one of those people, but please feel free to do that if that makes you feel happy, because that's an awesome way to check your work, right? Sometimes we think we know what we're doing, and then it's like, oh, snap, it didn't work out. Number 2 is an example of having variables on both sides of an equation. So I always want to move the variables to the left, but and in this case, I see why, because if I move this -2 over here, I'm going to have a positive x value. Working with negatives, that's sometimes where I make mistakes, you know, silly things happen. So that's what I'm going to do. I'm going to add 2x to both sides to move it over. Right, it's gone from that side, and now x plus 2x gives me 3x minus 30 equals 6. I want to move my numbers to the other side of the equation. Right, so I'm going to move this 30 over here by addition. And now I have 3x equals 36. And this is easy peasy, right? We just divide both sides by 3. And x equals 12. I'm happy with that number. Does anybody have a question? Okay, cool beans. We only have a couple more examples and we good to go. Is it okay if I change this page? You guys are such good students. I would give you candy right now if I could. Oh man, fractions. I know you're like, woo, I love fractions. They're so cool. No, you're not really saying that. I know that. I'm just kidding. All right, so with fractions, again, this is a coefficient to x. So I'm going to worry about this last. I want to get this 9 over here to the other side. Because it's positive, I'm going to subtract. So I have 3/7 x equals 6. Yay. All right, so I don't know if you remember this funky rule, and maybe you want to write this down, okay? Because we can't divide by fractions. That's like a no-no. We multiply by the reciprocal. The reciprocal just means we flip it upside down and multiply. But whatever I do to one side, I have to do to the other. That's a dot. I don't know why it does that. Okay, so I'm going to multiply both sides by 3/7. On the left side, they cancel each other out, and out comes my x. But on the right side, there are two ways to do it. You can go ahead and multiply 6 times 7 and then divide by 3. Like build up a big number and then break it down. Or you can go ahead and cross simplify. I say 3 goes into 6 twice. It goes into itself once. So this is a 1 and this is a 2. And 2 times 7 is 14, which is also the same as 42 divided by 3. But to me, that just makes it easier to me. But you know, it's not gonna, up to you. All right, so fractions, make sure you multiply by the reciprocal when you're trying to divide or thinking you want to divide. All right, and number 4, here's another common mistake people make when there's subtraction signs in front of a parenthesis. You must distribute this negative sign into both terms here, because I want to get rid of those parentheses. Remember order of operations, right? Parentheses got to go. Negative times positive is a negative, right? So there'll be negative 2x. And then negative times positive 1 gives me negative 1. Now my equation looks like this. And I need to combine like terms on the same side of the equation whenever that's going down. So I have a 3x minus 2x. That gives me 1x, or just x, minus 1 equals 21. Well, now it's just a one-step equation. I'm just going to add 1 to both sides and be done with my day. X equals 22. There, very good. Any questions about those two? All right, I have one more example we're going to do. It's pretty beefy, but it's related to these solving equations here. So go ahead and take a moment, write this down, and try to solve it. And then when I go through it, see if you got the right answer. All right, I'm going to distribute first because whenever I see parentheses, that's what I want to do. But I'm going to pull this down. It's too far up. And don't forget, when you distribute -4 to -1, that gives you +4. Negative times a negative is a positive. On the other side. I got a hot mess. I need to clean up the left side, combine like terms, and clean up the right side by combining like terms. I'm going to bring my x's together and it's -6x plus 4 equals 7x minus 4. I always move my letters to the left, and I know it's going to give me a bigger negative, but it's going to be fine. Oh, wait a minute. Hold on a second, folks. I realized when I distributed for number 5, -4 times x is not -8x. So reduce. It's -4x. I was just seeing if anybody's paying attention. You guys left me hanging here. Just kidding. Sorry. Then obviously when I combine like terms, 2x minus 4x is -2x. Oh, for crying out loud. Okay, now I'm ready. Sorry. I'm going to move my letters to the left by subtraction because it's positive here. -2 minus 7 is -9. my gosh, I'm making all kinds of mathy mistakes here, kids. What's happening? When I distributed, so see, it happens. We all make mistakes, right? When I distributed the second time, I just noticed 2 times -1 is not -4. So that messed me all up over here. I don't even know what's going on. I apologize. I hope you guys were using 10. What did I get? For crying out loud. Wow. If you thought you made mistakes, maybe you didn't. Maybe you should just wait till I get to the end. Okay, so you should have down here -9x plus 4 equals -2. Subtract 4. -9x equals -6. We always want to divide by whatever is in front of the variable. So right now I have -9x equals -6. I need to divide by -9. And now that gives me x is all by itself. And a negative over negative is a positive. So I have 6/9. If you have a fraction that can be reduced, you must reduce it. So 6/9, they have a common factor of 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So this answer is now x equals +2/3. And I'm going to write 2/5 because I do what I want. Wow, that was challenging. Anybody get that right? All right, I'm going to say by your silence that you all got it right. So that's awesome. That is what I have for today. Okay, this was a pretty challenging problem. And I ended up with a fraction answer. So I might have been inclined to go back and do it again if I didn't have my answer key sitting in front of me here, because I know what the answer is. So if you do get stumped, just come back to the help support and I will be here waiting for you. But I'm going to turn to the next page. This is your assignment for today. It is a worksheet. It is in Schoology. If you can write on it, I think it's in a document. You can type on it. I'm not too worried about you showing your work. It might be tough for you to type in radical signs. I'm not sure how familiar you guys are with Word, because there is a way to insert math. But I'm going to stop recording here if I figure out how to do that.